Welcome to week 7, day 30 of the fall 2024 programming fundamentals with C Sharp. This is Jim Kaufman with Rankin Technical College. So what we're going to be covering today, we're going to just do a quick little review of, things we kind of learned in chapter 12. Then we'll go ahead and lecture over 14, which is how to work with inheritance. And we'll also look at some coding examples as well on that. So in this last week, we learned how to create our own classes. We learned how to add classes to our projects, how to access a class from the forms or other classes. We learned how to read the UML class diagrams, the unified modeling language class diagrams, and how to create code from them. And we also learned the principle of encapsulation, which is kind of the concept of data hiding, where we can make our instance variables private, and then we can control access to them. Now I know when we're coding, some of that doesn't probably quite sink in because we're in control of our own classes and that. You think, well, how are you hiding data here? I could just change it, right? But the concept really is, let's just say that you've built some project or maybe some whole class library that you're allowing other programmers to use that class library. Well, what you would do is you would compile that class library so that those programmers, they wouldn't have really access to your code. They would just have access, you would provide them with, documentation on how they can use your code, but they can't really access your classes and so forth. They can inherit from them, and they could use them in certain ways, but it's hidden, there's some hiding from them. And so when you go ahead and would create those like private instance variables and use certain properties to access them, you are in fact hiding that from them certain extent so that they have to use it a certain way. They can't just go and change whatever they want. You may not want them to be able to set certain variables, so you just provide a getter method, right? And we had some different labs where we just had get properties and we didn't have set properties, and the only way they could actually add data, right, to set those variables, they had to use that constructor, right? They had to use that overloaded constructor that had all those different parameters that they passed in, right? So you kind of control how a user, someone else, can use your code, right? One thing I did want to mention. Okay, we just wanted to go over here a list of the assignments for week 7. So we'll have a hands-on test for chapter 12, hands-on test, and I'll make that visible. Tomorrow morning at 7 a.m. and it'll be due on Wednesday or Thursday by 7 a.m. on Thursday morning. And then we'll have 2 written tests, one on chapter 14 and one on chapter 15. And then we're due Sunday by midnight. And then also we'll have chapter 14 and 15 labs due Sunday by midnight as well. So the chapter 14 and 15 labs, it's not as extensive as what we did on chapter 12. So it should be a little easier week for you here. So we'll cover those later. All right, so let's go ahead and start looking through some of this chapter 14 stuff here. So chapter 14 is how to work with inheritance. So inheritance allows you to create classes that are based on another class. And actually, let me show you real quick here, even though you probably might not have realized it, or maybe you have. Let me show you something here. we actually been doing it all along. So if you actually look at how this is structured here, you've got this colon here. This is the class you created. This is by default what it calls a class, your form, right? So, but when you create a new Windows form, this is what it's going to use, form one by default, right? Well, this is actually inheriting, it's using inheritance. This is your base class is form. So this is actually a .NET form, right? And so if you go here, this is a good habit to learn how to do this if you haven't already. You can right click, go to definition. And I know, there's a lot here and, please don't get confused by everything, but this is actually the base form. This is the system Windows forms. This is within the namespace, but this is a form, right? And this is the base class. So whenever you create a form, you're actually you're creating a subclass of this form. Okay, even though you don't maybe realize it, that's what you have been doing. So inheritance allows you to create a class that's based on another class. So when used correctly, inheritance can simplify the overall design of an application. The following topics present an introduction to the basic concepts of inheritance. So you need to understand these concepts before you can learn how to write code needed to implement classes and use inheritance. So when inheritance is used, a derived class. So you'll see these different terms, and I know it's going to take you a while for all this stuff to sink in, and it can become very confusing. So, like what we were just looking at, when we create our own form, we create a derived class from that base class. That Windows form is the base class. Then you've actually created you inherit it from that, and you derived a class from that, and that's your own class. Now, also a derived class, can be different names that mean the same thing. And we'll go through this a couple different times here. So a derived class is one term to talk about the class that you created from the base class. It also can be called a subclass, or it could also be called a child class. So a lot of times it depends on, it's kind of from the context of what you're doing. What term kind of really works the best. And what I mean by that is, like, let's say you're building a family tree, right? You've got you have grandparents, then you have a parent, you have two parents, and from those two parents you have a child. So there it's very logical to think, okay, here's a parent. A parent is the base class, and the child is a child class of parent, right? So you can do a parent-child relationship. That makes sense, right? But sometimes, that when you're conceptually creating something, that doesn't always kind of make sense, because sometimes a base class can be something different than, that kind of specific thing, right? Maybe like an animal, and then you have a dog, right? So the animal class is the parent class, and then the dog is the child class. But from conceptually thinking about it, it kind of seems a little unusual, because really you don't are you really is it really like a parent-child relationship? Yeah, sort of, but maybe you kind of look at that more of a base class and a subclass, and there's other situations where that can be a little different as well. But we're going to go through that a few times so you understand that. But back to this, when inheritance is used, a derived class inherits the properties and methods and other members of the base class, right? So everything that you can define certain things in that base class, and when you derive a class from that, right, then you can use those methods that are already there in that base class, okay? The derived class can also provide its own members that extend the base class. The derived class can override properties and methods of the base class by providing a replacement definition for them. Okay, let's look at. So here's a situation where you've got a, they're showing you the, I'll make this just a little bit bigger here. I can. I hate how Teams kind of prevents me from doing some things that I'd like to be able to do. But here, you've got a base class and a derived class, right? In this case, you're say here's this system Windows form, right? So this is their base class, right? And then here's a derived class. This is the one that you could have created, right? This was I know we looked at a product maintenance application. So this is creating a new product form, right? And so everything in here can be inherited from here, right? It's inherited in here, but also you may add your own things, right? You add your own, your own text boxes, whatever text boxes, check boxes, your labels, all that stuff. You're creating new ones, right? Okay, and even though those are specific to your class, right? The ones that you create. So here's the base class, which is the system Windows forms. And then here's the derived class that you created. And like we just looked at here, here's the class you created. Here's your derived class. Here is the base class, right? And this is how you write this in the code, right? And you use the colon in between, right? You're saying that your derived class is inherited from this base class. Okay. So inheritance lets you create a new class based on an existing class. Then the new class inherits the properties and methods and other members of the existing class, right? The base class. A class that inherits from an existing class is called a derived class, a child class, or a subclass. They can be used interchangeably, okay? A class that another class inherits is called the base class, or parent class, or superclass, right? So here we were talking about this is the base, on the left-hand side, this is the base class, and this is derived class. And kind of also mentioned maybe like if you were creating a family tree, you would have, a parent-child relationship, right? And that makes it very easy to understand the parent-child in that situation because it actually is a true parent-child relationship, right? You inherit DNA from both of your parents, right? So that's kind of a parent-child relationship there. So a class that another class inherits is called a base class, parent class, or superclass. It can also be called the superclass. So you just have to learn that terminology, and you'll get used to it as time goes on, right? A derived class can extend the base class, okay, by adding new properties, methods, or other members to the base class. So that's just, you inherit what's already there, and then you add your own, right? It can also replace a member from the base class with its own version of that member. Depending on how that's done, it is called hiding or overriding. When you create a new form in C#, the form inherits the .NET class named System Window Forms. As a result, all C# forms inherit the members defined by this base class. Then as you add controls and code to your form, you extend the base class by creating a new properties and methods. Okay. So yeah, let's go ahead and skip from that. So here is, this might be a little bigger here. Let's see if this one's out. It's not really any different. But okay, so here, this is the inheritance hierarchy for forms and control classes. So this is the namespace, this the system Windows Forms namespace, and it has these different objects, right? It has a control object, different control objects. You have a and it has a button base, a group box, a label, list control, text box base, and a scrollable control. Okay, and then here you've got a button base. So the parent of button base would be control, right? That's the parent of button base would be control, right? So then button inherits from button base, which inherits from control, right? So all three of these, button, checkbox, and radio button, are all subclasses, right? They're all subclasses, derived classes, what you want to call it, right? Derived or subclasses of button base, right? Same down here with the list control. List control would be the parent of a combo box and a list box. All right. And then here it's just showing you one of them. Text box has a text box base, and then text box inherits from that. So .NET uses inheritance extensively in its own classes. For example, inheritance is used throughout the system Windows Forms namespace. All of the control classes are derived from a control class. This class provides properties and methods that all controls have in common, right? So all of the different methods and properties that control has, it passes down to its children, right? Or it's however you want to look at it. Children are derived classes, right? So button base is going to inherit from control, right? And it may have button has some specific things that it introduces new things that control didn't have, right? So button base will get everything the control had, plus button base is going to add some of its own stuff, right? And then button is going to inherit everything from button base that also included everything from control. So button will have everything that button base had plus control, okay? And then button will add some of its own, right? So the farther down you go into the tree, the more specific things that will be there, right? So all of the control classes are derived from the base control class. This class provides properties and methods that controls have in common, such as tag and text, right? So we, how when we create a control, when we do a box or a label, a text box or a label, we have that .text property, right? Well, that text property was actually inherited from a class ahead of us, right? And we down a base class on top of us, right? Some controls have additional layers of inheritance. For example, list control class provides features common to list box and combo box controls, such as selected value property. Yeah. So it's just showing you that, there are some certain things that may be specific just to certain, areas. So the list box here, list control. List control is going to have some certain things that label and group box and button base don't have, and it's going to have those available to be inherited by your combo box and your list box, right? So every class implicitly inherits from the system object class. Just to review a little bit, when we're talking about implicitly, it basically it's pretty much what you kind of look at it, think of it implicitly automatic, right? It automatically inherits, right? Inherits from the system class. Sometimes explicitly, if you recall, that's where you've kind of got to tell the code, hey, I'm wanting to, I'm wanting something, right? And we did that explicit, implicit have to do with like primitives, right? I'm gonna confuse you with objects and that, but we're going to do implicit, explicit with objects as well. But with primitives, sometimes we had to explicitly, when we had casting from one type to another for primitives, there was two different types, right? There was implicit and explicit. Implicit when it was automatic kind of thing, and explicit is when we had to tell the code, hey, it's okay to do this, right? And usually when we're doing explicit, it's because we're losing something that we've got to say, okay, we understand that we might lose something, and that's when you would be doing from a primitive standpoint, like you're something that's got a decimal place, right? If you got a decimal place and you're trying to change that into an integer, you're going to lose your decimal place. So that's when you explicitly have to tell the code, okay, I understand that I might lose something here, but it's okay. I'm fine with that. So you have to explicitly tell the code, go ahead and convert this to an integer. I'm okay with losing my decimal places, right? And the same thing is for objects as well, okay? So we're going to get into that a little more, but it's basically saying every class implicitly inherits from the system object class, okay? So in other words, system object class and the base class for every class, including user-defined classes. This means that all classes inherit the methods that are defined for the system object class. These objects are summarized, okay, in here. So let's go to that. So here's, on the left-hand side, here's the methods of the system object classes. You got a toString, equals, reference equals, get type, get hash code, finalize, and member-wise clone. Okay, you don't have to worry about all of these. Some of these you might have already seen. toString, maybe the equals method as well. But we'll be using these. Definitely toString, you're aware of that one. Equals, we're going to look into that a little more. We're going to look into how that's used and how we can overwrite these as well. Another thing I wanted to bring up. So when you create objects, they're there. You create them in memory. And let's say, you create an object within a method, or let's say you create an object in a method. And as we know, we talked about, after you leave that method, it's pretty much gone. Well, it's not really, and especially from an object standpoint, objects are stored differently than primitives. And we'll go into that in more detail later on within the course. But objects are stored differently in memory than primitives are. But just in general, we talked about how, like, if you're in a method or any block of code, right? It could be an if statement or a for statement. You create a variable, and that could be a variable that's associated with a primitive, or variable could also be, like we started doing this past week. We created variables that are references to objects, right? Right, and so when you create those variables, being primitive or object references, within a block of code. Once you leave that block of code, we've learned that that's gone. You can't reference that anymore. But in memory, it doesn't quite work exactly like that. Even though you may not be able to access that object just kind of still remains in memory a little bit. Even though you can't use that reference to get to that again, but it does. It's just the way the different programming languages work, and it's not just C sharp. There's other other programming language as well, like Java and so forth. And so what it will do is the object will kind of still be there, and there's a process called garbage collection, and it'll actually clean up those objects, and it can start. It can run at different times. Usually it's pretty quick, and most of the time that stuff happens especially in small applications. It's happening so fast you don't even know it. And I mean, from a human standpoint, you can't tell, right? It's so fast. But there's sometimes, especially more complex applications, those objects just reside in memory for a while until they get cleaned up. Okay, but eventually they will get cleaned up, and that's kind of called garbage collection. And garbage collection automatically manages memory. So when the garbage collector determines that a system is running low on memory and that the system is idle, it frees the memory for any objects that don't have any more references to them, right? So that's the important point right there. Because like I said, when you're in a method, once you leave that method, you lose reference to that. But that object could still sit in memory. And these different programming language, such as C Sharp, they have what's called garbage collection, and it automatically manages that memory. And it don't always go clean it up right away. It's not there's not any specific rules to how. I mean, there is within the language, but us as humans and programmers, it's hidden from us how that all happens, right? But you just have to realize that sometimes objects do stay in memory, and you don't have to really worry about it too much in your code. But it's the times you have to really worry about sometimes about objects in memory is when you're writing a very complex application and you need to programming it a way that's very memory efficient. Because if you just keep on dumping objects in your memory, one after another, we're just dealing usually with small little lists, but you could have arrays of 10,000 objects, right? And so all those objects are going to be stored in memory, those 10,000 objects. So you have to code, you have to be very cognizant in what you're doing, because you don't want, if how it is, like on a computer, like when you're running out of memory, it just bogs down. The same things with an application, right? So if you're dumping a bunch of objects in memory, then there can be problems, right? So you have to be smart on how you write your code. And for the stuff we do in this class, it's really not relevant. But in the real world, when you've got very complex applications, it means much more. Okay. Let's see. Let's make this a little bit bigger here. So these are some of the methods of the object class, right? So whenever you create a new object, so we've created objects, in chapter 12, we created a, order object. We created, our soda object, right? Our Sunday object, right? So all of those objects that we created, I do want to go back. How we looked at the forms, when we create our own form, it's going to inherit from the parent form, right? The base class form, the .NET one. But when you created your other objects, right? When you created your soda object, your Sunday object, that doesn't inherit. Them were standalone objects, right? They didn't inherit from that. But what they do inherit from is the system object class. So every class you create, right? Every time you create a class, right? It's going to inherit from this system object class just by default, okay? And then these are these certain methods that are available in all these classes that we create, right? These standalone classes. So there's a toString method, which returns a string that contains the fully qualified name of the object's type. So, and we're going to go to get into this a little more, but sometimes, and actually it's a very good debugging tool too, is like, let's say you've got a bunch of variables, let's just say you have a bunch of instance variables declared, okay? You have a bunch of instance variables declared so that, and you're holding data in there. What you can actually do, excuse me, is you can overwrite this toString object and print out all of those variables. And I'll show you here in a little while that the toString object, like I said, it's just going to actually print the name of your object. It's just going to go namespace dot and the name of your class, and that's all it's going to do. But if you can overwrite that toString object to basically print out, so to speak, all of the variables that you have assigned. So all of the variables for that object, it'll print those out. So it's a very helpful tool. We'll look at that, right? And also an equals, right? So we returns true if the object refers to the same instance of the specified object. So basically, you're just comparing two objects. That's kind of confusing how they say that. You compare two objects. Does this object equal that object? If it is, it returns true. If this object is this object not equal to, it's going to return false. And we're going to look into that because with objects, it's very it's much different because if you recall, we use the class as the blueprint, right? And then from that blueprint, we instantiate objects. And every time you instantiate a new object, it is separate. So they are not equal to each other, okay? So we're gonna go through that a lot more and talk about how equals works with that, okay? Because there's some important points to that and how that works. And then so it has more than one equals method. This one is you compare two objects to determine if they are equal to the same instance. But we're gonna look at both those different equals methods. And then here's a reference equals. It's a static method. And as a review here on static, if you recall, like when we do a console app, it has a static main method, right? And the reason it's static is because when it runs, it has to have an entry point into that console application. And the only way to get in, to enter into that is you can't have an instance of it. You have to start an application from the beginning. You have to be able to get into that class, and the main method is an entry point into that class, right? But it's not an entry point into objects you created, right? It's not an entry point into objects you created. It's an entry point into that class. And whenever the difference between, static, whenever you make something static, it means it can be accessed by the class itself. It can be accessed without creating new objects, okay? Anything that you see that's ever static, always think in your head, that can be accessed without creating a new object first, right? So, you've already created some new objects. We did that, in our Chapter 12 labs where you created new objects. And you create new objects to access other things, to access some variables, to access some methods, right? You had to have an instance of that class. Well, anything that's static within a class can be accessed without an object. And how you do that is access the name of the class dot and the name of that static member. Okay. But we're going to look at that a lot more as well. Um, and so that's just telling you that these are static. That the equals method and this, you don't have to have an instance of an object to use these methods, right? These are considered class methods, right? They belong to the class and not an instance of an object. And get type returns a type of the object that represents the type of the object. And then, that's important inheritance, and we'll see that a little more. Get hash code returns an integer hash code for an object. And a hash code is just a hash code is just like a number that's created, that represents an object. It's used in different places. We'll go into that more here in a little bit. I don't want to get into too much of that right now. Finalize is another method. It frees resources used by a class. This method is called by the garbage collector when it determines there are no more references to the object. So finalize, so maybe you create some class and part of that class does some outside call, okay? I know we're not really doing this, but our classes could call something off the internet. Maybe there's a URL it uses to grab data off the, from some other place that's providing data, and you're pulling that data into your class. Well, sometimes you have to make it like a connection to that. It's the same thing with like a database. You have to make connections to the database. There's all these rules you follow to make to make a connection to a database. Well, if what you want to do is when your object goes away, you want to clean up all that. You want to clean up that connection, right? So we'll look at that more. But in a finalized method, that's something where you clean up. You can clean up resources. Okay, close this connection, close this. It's kind of like a cleanup method where you clean things up, and that happens when that object is called by the garbage collector. It'll just clean up all that stuff. Okay. Memberwise clone. This just creates we'll go into this more. Creates a shallow copy of an object. Okay. So it creates a copy of an object. So to review here, the system object is the root base class for all classes. Okay. In other words, every class inherits either system object or some other class that ultimately inherits system object. So we were looking at how we create our own forms, and that inherits from the system forms, right? But even system forms inherits from system object as well. So any class that's created anywhere, always every class, every object always inherits from system object. Okay. When creating classes, it's common practice to overriding the toString and the equals method so they work appropriately for each class. Okay, and so for example, the toString method might return a value that's uniquely identifies an object, and the equals method might compare two objects to see if their values are equal. Yeah, so that's one thing. We kind of just spoke about a little bit. The equals method. If you let's say you create an object and it had a name. Let's say the name was Ted. Okay, and then you create another object and also had a name Ted, like we were saying before. So you instantiated two different objects. If you asked if the first object and the second object are equal to each other, it would be false because they are stored in memory in a different place. They are actually two different, distinct objects, right? Even though they have the same name, Ted. Well, what you can do is you can overwrite that equals method, right? You can overwrite that equals method that actually uses a string comparison and compares the properties, the compares the different values that are in one object to another object. And that's one way to, and you would overwrite the original equals method that is in the system objects class. You would overwrite that for your own purposes. And so you would overwrite that and would use the name, the name, which in this case was Ted. And so basically it would compare both objects by the name, and if both equal Ted, it would return true, right? So that's one way. That's how you override an equals method, right? And we're going to look into that a lot more as well. The hash code for an object is an integer that uniquely identifies the object. And so, like object instances that are considered equal would return the same hash code. So, like we were talking about before, we were talking about that example with a Ted name. If we did a hash code, on just two distinct objects, right? And we use the default equals method, right? They're not equal to each other. It would actually return a different hash code, right? But if we overwrote the equals method, and I do want to also say that if you overwrite the equals method, you also have to overwrite the hash code method as well. Okay? And you would overwrite that hash code method so that when you compared the object that had a name Ted to the other object that had a name Ted, and when them are equals to each other, okay, you would also overwrite the hash code method so that they would return the same value. Okay? And we're going to take a look at that. And then we also talked about the finalize method of an object. It's default implementation. The finalize method doesn't do anything. It doesn't have anything in there. But, that can be overwritten. And once you overwrite that, that's a place, you always think of that finalize method as something that, it's something that you want done. It's kind of a cleanup. Think of it as a cleanup method. That when your object's destroyed, that's the word used, destroyed. When your object is destroyed, when that memory is reclaimed by the garbage collector, it's going to run that finalize method, and anything you have in that finalize method will execute. Okay. Okay. Oh, didn't mean to do that. All right, let me get back to where I should be here. All right. So the two main ways inheritance is used in business applications. First, it can be used to simplify the task of creating classes that represent similar types of objects. So, that's pretty much the reason, you want to do that. One of the reasons you want to do that, you can create a base class that has all these methods, have different properties. So then when you create another object, when you create another class from them, you inherit all that. So that way, the other way, you don't want to, you create different classes and then copy and paste them all in there, right? That's not very efficient. It's better to follow a inheritance hierarchy so that you can inherit those different methods and fields, and it just saves you a lot more coding. And there's other things you can do with that as well. Okay, so it's basically two ways inheritance use. First, could be used to simplify the task of creating classes that represent similar types of objects. For example, the first inheritance hierarchy in the figure shows how you might use inheritance to create classes for two types of products: books and software products. As you can see, the product class is used as the base class for the book and software classes. So here on the left-hand side, you got a product, and you're inheriting the book and software from product. And that's where, if you recall, we looked at the form and how you use the colon. So within your book and software classes, you would have a colon and product. So that means that product is your base class, book and software is your derived classes or subclasses, correct? So these subclasses inherit the code, description, price, properties, as well as the get display text. So they inherit all these, and they could use them just as they are, or they can overwrite them. Okay, right? The second inheritance hierarchy, is that over here or not? I don't think so. Okay, the second inheritance hierarchy in this figure shows how you can use the .NET classes as base classes for your own classes. Oh, it's down here, I'm sorry. So down here, the second part down here, a product list class inherits, this product list down here, inherits from the system collection generic list class, and it inherits these properties, right? And basically, you're like we kind of were looking at all our form controls. There's also all of these other system type things we use, like collections and so forth, like list and that. All of the code, all of the system classes within the C# programming language are also hierarchy type things as well. So we inherit from them, right? Okay, an important aspect of inheritances is that you can use a subclass as an argument or return value for any method that is designed to work with that base class. For example, add method of the product list class accepts a parameter of type product. However, because both book and software classes are subclasses of the product class, you can pass either book or software object to the add method to a book or software product to the product list. We'll look at that. That can be a little bit confusing. We'll look at that a little more, obviously. So here shows how to create a class that can be used as a base class. So you don't have to do anything special. So like basically all of our objects we've already created, they were standalone, but you can look at those as base class. We didn't inherit from them, but a lot of the things that we did create maybe could be inherited from, right? So ours were standalone, but basically you just create, just like we've created other classes for the Chapter 12 labs, you would do the same thing to create a base class, right? You're not stating that it's a base class, right? It's kind of just when you extend it, when you put that colon in the name of it, that's when you pretty much state it. Oh, yep, this is a base class, right? Um, so yeah, another important thing is this virtual keyword. So if you want a class that's derived from this class to be able to override one of its members of the base class, you include the virtual keyword. So for get display, when you do get display, you're going to want that different for your software than for your book. So you want to override it. So to be able to override it, you need to, in the base class, you have to state that this is virtual. Okay. Now I did want to go through this real quick. Access modifiers. So we've seen our public we're aware of, internal, and private. Pretty much, public is available to all classes. We know that. And that's another thing as far as we talk about encapsulation and stuff like that and data hiding. You know, you know, access modifiers are very important to the whole concept of encapsulation. So you want to control who can access certain things, right? So for public, it's available to all classes. Sometimes that's the case. You want everybody to be able to access something. All of our properties. When I'm referring to our properties, those the gets and sets, getters and setters, the get and sets of a instance variables. Them are called the properties, right? So to be able to change any of them, you pretty much have to make them public so someone can change those. Okay. So protected's available. So protected's a different keyword. It's available only to the current class. So anything in that current class or to the derived classes. Derived classes or subclasses or child classes, they're all the same, right? So if you use protected, it's only that's only available to that current class and all of its derived or subclasses, right? Now we have internal. It's available only to classes in the current assembly. And when we're saying assembly, it's really just where you are in that code. Let's look at let's see if I can find. Oh, maybe I'll just show that later. Maybe it's just best to show that later. We'll review them in the code itself. So protected internal is available to the current class, derived classes in the current assembly, or derived classes in other assemblies. So when you do protected internal, it's available to the current class, okay, derived classes in the current assembly, or derived classes in other assemblies. That can be pretty confusing. So we'll definitely be reviewing that a lot more. Private protected, available to the current class or to derived classes in the current assembly. And then private, which we've already used, is available only to the current class. Okay, let's see here. Okay, the syntax for creating subclasses. To declare a subclass, this is where you actually use the colon, right? So here's your subclass name. And the second one's your base class name. So to create a constructor that calls a base class constructor, we've already done this, right? But it's a little different here with the base class. This we'll look into this. To create a constructor that calls the base class. So from your subclass, you can call the constructor from your base class, right? And this is how you would do that, okay? And we'll look into that. To call base class method or property, you just have your base, the name of your base, dot method name, or property value, like that. To hide a non-virtual method or property, to override, to hide. I don't think that's right. Don't look right to me there. To hide a non-virtual method or property, it ain't going to be public, but new type name. Yeah. We're going to have to look into that. I'm going to have to look into that a little more. To override a virtual method or property, you override. You put the term override. Here it's saying you put the term new, and that's probably right. I just need to look into that. That's different from what I'm used to. But to override a method, you put the word override. And so in your code, I shouldn't say your code, but the subclass, you're going to see override with the same name of the method, right? Same name of the method, same type of name of the method. But if in the base class and its parent class, you're going to see virtual. In the subclass, you're going to see override. So an abstract class is a class that can't be instantiated. So like how all of our classes that we created, we call a constructor to create a new class, a new object from that class, right? But if you've got an abstract class, like this one over here on the left-hand side, let me make this actually a little bigger here. So this abstract class that we have defined over here, this cannot be instantiated, okay? It can be used only as a base class that other classes can inherit. So declare an abstract class, you include the abstract keyword in the class declaration. And I'm using a different example on what they are. Then you can code any members you want within this class. Now, if you notice something different here, abstract methods, you can also have abstract methods, right? And if you use an abstract method, then there's not a body to this. And what I mean is you didn't implement anything in here. You just declared it. Hey, I have a method called make sound. Okay? And then what that does is it basically says to any subclass, any other class that would use this class, right? This animal would ever use this as their parent object, right? In this case, you got dog. Dog is a subclass of animal. So anytime you do this, what you do is you have to overwrite the make sound. You have to, and this is called providing a concrete implementation. You have to create a concrete implementation of this abstract class. Okay. So when you say that this has no concrete implementation, make sound, it's just open and close, and you see it's got a semicolon. We're used to creating methods where we've got the open and closed curly braces, right? Well, that's when you do that, you've basically you've got what's called a concrete method. You provided an implementation of make sound. Here, there's no implementation. There's just a declaration. Okay. Now, every base class don't have to be abstract class. It's a option. It depends on what you're trying to do. Okay. You may not want to instantiate this animal object, right? You just want to create this, and you want every animal that uses this base class, you're going to provide your own make sound, right? So that's how that works. So here, dog, you're making a sound wolf for the dog. For the cat, doing meow, okay? Bird, you're doing tweet for the bird. So you're providing for an abstract method that was created in the base, you're creating what's called a concrete implementation, okay? And then here's basically, well, you're creating an array of animals. So you can refer to your object, this animal object, like this, right? But you can't create a new one. So here you're just creating an array of type. This is your type of type animal, right? And so you're creating an array called animals, and then you're creating within your array 3 new objects, one a dog object, one a cat object, one a bird object, right? And then here you're doing for each. So even though this is a dog object or a cat object or a bird object, it is also of type animal. So you can, a dog is an animal, right? A cat is an animal. A bird is an animal, right? So in this case, you're using a for each here, and you're walking through all 3 of your, even though you created with new dog, new cat, and new bird, right? These are still considered animal objects, okay? Because they inherited, they are of type animal, right? A dog is an animal, a cat's an animal, and a bird's an animal. So here you're just doing animal make sound, right? So in this case, it will, it's going to, for each one, it's going to call this make sound method, okay? So here, let me just make this big. Actually, I think I'll do this so we can kind of look at both here, I guess. Let me make this a separate thing. Make this a little bigger. So abstract class, an animal class is defined as abstract using the abstract keyword. It contains an abstract method called make sound. Abstract methods have no implementation within the abstract class itself. No implementation of this method, right? Just a declaration of this method. Subclasses of animal must provide their own concrete implementation for make sound. Then you have what's called these concrete subclasses. And when we're saying concrete, it's always when in a situation where you are doing, you're extending a base class, right? You're inheriting from a base class that's abstract, right? That's when you're really talking about creating a concrete. When you hear concrete, that's usually it's not just a regular parent class like we looked at the other classes, right? It's basically when you use an abstract, okay? And so when you use an abstract, you've got to provide a concrete implementation of make sound in each one, right? So the dog, cat, and bird classes inherit from animal. Each subclass overrides the make sound method to provide its specific implementation. Okay. The override keyword, as you can see, each one of these on the left have an override keyword, indicates the method is overriding the base class method. Okay. Now I did want to bring up, and this is a concept that's going to probably take some time to really grasp. So one of the concepts regarding object-oriented programming, inheritance is one. For a language to be object-oriented, it has to have certain things, right? It has to have, it has to be able to have encapsulation, and polymorphism inheritance is another one, right? And polymorphism is another one, okay? So And this concept is going to take take a while to understand. So don't worry if it doesn't come to you right away. So here the main method creates an array of animal objects, right? So we've seen this array of animal objects, but the actual objects are instances of dog, cat, and bird, right? So dog, cat, and bird, these are the actual instances, right? The for each loops iterates over the array, calling make sound. Okay, and actually I just want to, the fact of this being in this array has nothing to do with polymorphism. We're just referring to this example here, okay? But the for each loop iterates through the array, calling the make sound method on the animal object, okay? So at runtime, right, at runtime, even though you're using the word animal, define these as animal, and here you've got a reference to animal, so you're saying each one's an animal object, right? When you call animal.makeSound, right, it's actually going to call the method that's in dog, cat, and bird. It can be a little bit confusing about that. You think, well, animal has that method, right? The make sound method, but it doesn't call that, right? It's going to call the concrete implementation that you have in your dog, cat, and bird classes, okay? So at runtime, the appropriate make sound implementation is called based on the actual type of the method, the actual type of the object. And that's demonstrating polymorphism, okay? So key points here about, about polymorphism. Polymorphism allows objects of different classes to be treated as if they were the same type, right? So it's treating all three of these, dog, cat, and bird, which, they're all different, right? We know a dog's different than a cat from a bird, but we're treating them as if they were the same type. We're treating them as a type of animal. We're treating them as animals, right? So abstract classes provide a template for subclasses. Let's make this a little bigger, smaller. Abstract classes provide a template for subclasses, ensuring they can implement certain methods. Overriding methods allows subclasses to provide their own specific implementation. So this example demonstrates how polymorphism can be used to create more flexible and reusable code. Like I said, don't worry if you don't understand about the polymorphism. And there's different, it's a lot more. There's a lot more involved than just this example. But we'll review this. We'll go over polymorphism multiple times. I just think that this is a pretty good example in a way because it's showing you that allows these objects of different classes to be treated as if they were the same. You know what I mean? It treats them as a common animal, so to speak, right? It treats them all as an animal, right? And allows you to, but it will call the correct method, okay, based on what type of animal it is, dog, cat, and bird, right? So that's that. Let's go through. So the core concepts of object-oriented programming, include encapsulation. And so, we looked at that already, right? That is, building data, properties, methods that operate on the data within a single unit, right? It hides the internal implementation details of an object from the outside world. Now the encapsulation, we looked at that more from a perspective of, hiding those properties, right? But, you can also, it can be a little more than that. You can also hide methods and other things as well, right? And we'll see that more as we continue on in this course. So you just have to remember encapsulation has to do with, basically hides the internal implementation details of an object from the outside world. And you want to do that, so you can control what happens and as opposed to when you make everything public in your class, and that people can do all kinds of things, and they may get results that were not intended by the code that you intentionally wrote, right? So an example, a class can have private properties for name and age, and a public methods to get to these properties. This ensures the data is accessed and modified in a controlled way. And that's what we've seen, from our experiences using those private instance variables and using those properties, the get and set of properties to access them, right? Access or set them. So that was encapsulation. Inheritance, we were talking about that here today. Creating new classes, derived classes based on existing classes called base classes. The purpose promotes code reuse. Creates a hierarchy relationship between classes, and also enables polymorphism. Okay. The dog class can inherit from the animal base class, inheriting properties like name and methods like make sound. Then we talked just now a little bit about polymorphism. So about polymorphism, the ability of object of different classes to be treated as if they were the same type. So we had a list of animals of dog, cat, and bird, right? And we make sound method on each animal without knowing its specific type. Because, we didn't know if it was a dog, a cat, or that. We just said animal dot make sound. We didn't even know what kind of, from that code at that point in time, we didn't know what it was, all right? But through polymorphism, it chooses the right class, chooses that right object, either a dog, cat, or bird, based on, at runtime, it decides, oh, this is the one you meant. This is of type dog, use this method, right? This is the type cat, use this method, right? And then this idea of abstraction. Simplifying complex reality by focusing on essential features and ignoring irrelevant details. The purpose reduces complexity, improves code reliability, and promotes modularity. Here's an example. An animal class might have abstract methods like make sound, which must be implemented by its derived classes. This allows you to define a common interface for the animals without specifying their exact implementation. Okay. And so we will expand on this and go into more details as we go through this course, the remainder of this course, because this is important to know. An interview question, this is knowing these kinds of things. An interview question, interview is very important. For a programming language to be considered object-oriented programming language, it's what are the areas of encapsulation, inheritance, polymorphism, and abstraction. Okay. 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 So I split my screen here. So the top here is the main method, and down here is kind of some. So I have some classes that are defined just within this one class. I have multiple other classes. I'm just kind of doing this for demonstration purposes. Obviously, these are just simple little classes that don't do much, but obviously in most cases, you're going to want to make sure that, when you create a new class, you create a standalone class, right, in your projects. But for just demonstration purposes. So I just kind of want to show you some here. So back to inheritance. Inheritance is object-oriented programming concepts where a class, the derived class, can inherit fields, properties, and methods, and other members from another class. The base class. This allows the derived class to reuse and extend the functionality of the base class. So here we've got an animal. If you looked at the bottom here, we've got an animal object, and it just has a speak method. Animal speaks, right? And then we have a dog method. Now, so we were just looking at abstract classes. These are not abstract classes, right? This is just a base class, base parent class, super class of animal. This one is not an abstract one. So in this case, we're doing a dog equals new dog. We do dog.bark and dog.speaks, right? So even here in dog, we create a new dog. We have access to what? We speak and bark, all right? And so if we run this, it's going to print out dog barks, right? It's going to actually print that out twice, right? But if, let's see here, what if we go ahead and get rid of speaks here? And now if we run this, the first one's dog barks, the second one's animal speaks, right? So basically what this did here is you called bark on dog, right? You called the bark method on dog, and that was this method down here, line 89. But the speak method was actually called from the parent class, the animal class, right? So it just shows you can access those methods, you know, of the parent, right? The parent or the base class. So we put that back like it was. We run that again. So it's going to say dog barks again, right? Derived class. Kind of the same thing here. Oh, and that's kind of really what this was showing. It's that you're, in this case, it said dog barks twice, and actually the example here. So for the cat meows, so it's going to call, right? So the cat's going to call the meow, and then since it doesn't have any other methods here, when you do cat.speak, it's going to call animal, right? All right. So that's inheritance, derived class. I think, you know, you probably have a pretty good handle on what's a base class. The base class, a parent class, a super class, all the same thing, right? You just have to memorize and get that, you know, get that in your memory there. And then a derived class, a child class, and a subclass, all the same thing. It's all referring to the class that that you create from your base class, right? Overriding. So overriding is a process where a derived class provides a new implementation for a method that is already defined in its base class. The new method must have the same signature as the method in the base class. So this has to be the same, well, except for override. So virtual means it can be overridden, right? It don't have to be, but it means it can be overwritten. And then here's your overriding that speak method, right? So then when you call the dog to speak, it's going to print this one out. This doesn't exist. It's going to call the animal one. This is just showing, you know, this is probably covered in the book. So you can, a fully qualified name. So, but you know how we always use these console.writes like that over here on the right-hand side. We always use it like that. Well, you know, the fully qualified name is actually that. It's basically optional. So, but that's when you hear the word fully qualified, that means the full path, I guess, to the system.console.write line. You know, if you open this up, that's what it's going to be, right? It's going to be system.console.write line. Well, it's basically including the namespace, right? So namespace, right? Namespace, the class, The first one's the namespace, then the class, and then the method, right? I did want to go through a hash code here. So here we got person and person two. They both have the same name, John and John, right? And so if we go ahead and run this, what are we printing out? Hash code person one, hash code person two. So as you can see, the hash code for person one is different than the hash code for person two. Okay. Now, if we come down here, I already got this in person. Let's see if this works right. I hope so. So here, what's the name? Okay, I think we're good. So here we're overriding the get hash code, and it's basically basing the hash code on the name, which is the name that we have in here. So basically, it's instead of before when we seen it had two different hash codes. Hash codes are used for, like I know we looked at the collection dictionary. I don't know if anybody really used it. I think a couple people used it in their labs a while back ago. One of the collections is dictionary. It uses hash code, and it uses for quick comparisons and stuff like that to order things and to filter things based on hash code, right? Very much for sorting and stuff like that. Is it equal? If it's not equal, right? But it's also used for other reasons. And hash code is basically, hashing. I think I gave the I gave the example of an application I was working on, some while back ago that basically took in different users could upload different files. And when they uploaded those files, sometimes they would upload a file and they'd forget and they'd go and upload it a second time. Well, what we did is when they uploaded the first file, we actually create a hash from them. A little different than the hash code here, but the same concept. So when we created a hash from that file, okay, and it's not very long, actually. It's surprising how a small hash can refer to a big, long document, but it can. And so it creates a hash from that file, and we save that file in a database. So then the next time next time a user would upload a file, we'd get the hash of the new one. We would compare that and say, do we already have that? If we already have that, we would send a message back to the user stating that this file has already been loaded, right? Kind of the same concept, a little different, but same, just kind of wanted to, show you that, things can be hashed to be able to understand, to be able to use for comparison purposes, right? In this case, like we did, we created we got the hash code of these two different ones, person and person two, and since they're created as we instantiate new objects here, and since we instantiate new objects, they're individual objects, they're distinct from each other, right? So they have a different hash code. But we can do things to override things, and we can override to get hash code. And in this case, it's going to use name, and I hope this works right. So if I go ahead and run this, let's go to the hash code, and yes, it did. So person one, there's the hash code. Person two now, so it's the same hash code because it's using the name field as the comparison method instead of comparing them just being equal as. Because by default, the hash code is going to use the reference. Is this reference for this one equal this one? It's basically a reference in memory. Is this object also the same object as this? Is it the same in memory, right? And so even though we changed our hash code here, right, we overwrote the method there for the hash code. they're still in different places in memory. You know, each one is a distinct place in memory, but what we're doing is we're changing how we're comparing it. We said, well, we don't want to use the default get hash code, right? And that hash code was, if you recall a little bit ago, we seen that get that hash code in the object, right? In the system object, the Windows, the .NET system object, which is the parent of all objects, right? So we seen that that was already in there. And so basically what we're doing is we're overriding that just for our own purposes. When I say overriding it, it's overwritten just for our own object, right? When we don't override it for anybody else, right? Just only for our class. So we overwrote that just for that class. And in this case, we're using the name as the comparison, right? Okay, garbage collection, we talked about that, is an automatic memory management system in .NET that reclaims memory occupied by objects that are no longer in use by the application, preventing memory leaks. So, and just to reiterate on that, you know, so like you got a very complex application that has many different objects. You know, like the stuff we do, you know, we're doing simple little things, but anything really complex could be creating multiple objects in some method or that. And when you leave that method, right, the references to them objects is gone right away, but the object itself is still there in memory because the reference to the object is stored in a different place in memory than the object itself. They're stored in two different places, okay? And we're going to go. I want to go through that at some point, not right away, but sometime down the road about how objects and how things are stored in different parts of memory. But like I said, so the objects that are still resident in memory there don't automatically. You don't when you leave the method, they're not automatically cleaned up. There's a garbage collector that is part of the memory management system in .NET. That's going to reclaim that memory. So basically, it's going to destroy those objects. They're no longer used by application, right? And even though this is showing you how to call the garbage collector, forced garbage collection, it's usually not recommended. And even though you call it, it doesn't really, it's kind of one of those things that even though you call it, don't mean it's going to automatically do it right away for you. The system still kind of handles its own priority of what's it doing. It's kind of just saying, hey, can you go ahead and can you go ahead and force garbage collection? And you know, if that's what if it's got time, it'll if it's got time at that point in time, it'll do it. But it may be busy doing other things, and that's not a priority. So it's usually not recommended to call that, but it's just saying that you can call the force garbage collection, right? So we talked about a virtual member. And so our animal object here had a virtual member, right? And then we use the overwrite to overwrite that virtual member. So always remember in your base class, if you want to be able to make it available to be a method to be overwritten, make sure you define it as a virtual, okay? We talked about the different access modifiers. Public, private, and protected. We'll go through that some more. I'm not going to go... Well, we'll go through a little bit of that here. So, but, it'll get time to get used to that. But, just remember, you obviously remember private's going to be private within that class itself. Protected is going to be available within that class. And also any subclasses. So any other classes, subclasses, you can use that protected, right? And then you have this internal. Public is anybody, right? So a protected member is a class member that can only be accessed with its own class or by a derived class. So derived, child, or subclass. It's more restrictive than public, but allows inheritance-based access. So remember the protected member allows inheritance-based access. An internal member is accessible only within the same assembly or project. It is not accessible from other assemblies, providing a level of encapsulation. And just kind of remember, all of those access modifiers is all about really encapsulation. It's determining what you're going to allow access, who you're going to allow access to certain things, right? Are you going to allow access to anyone? Then you're going to make it public. If you only want to allow access to classes that subclass yours, right? Then you make it protected, right? So that's all about encapsulation. So an internal method access part of, okay, we already did that. Hiding occurs when a derived class defines a new member with the same name as a member in its base class, effectively hiding the base class member. The new member must use the new keyword to indicate this intentional hiding. Okay. Polymorphism, back to that. Polymorphism is the ability for different classes to be treated as an instance of the same base class. It allows methods to behave differently based on the object that invokes them, often implemented using virtual methods and overriding. I know we're reiterating things multiple times here, but I think it's important. The type of operator. A type operator returns the type of an object representing the type of a class or value type. It's often used for reflection. Yeah, that's a kind of a complicated concepts, but or to obtain metadata about a type. Okay. Name of operator returns the name of a variable, type, or member. String. It helps to improve code readability. All right. We talked about an abstract class. An abstract class is a class that cannot be instantiated directly. It is designed to be a base class for other classes, often containing abstract methods that must be implemented by the derived class. And what the concept of that being implemented by the derived class, a lot of times you'll hear, I don't think the book uses the idea of going, a concrete implementation. When you have an abstract method, you're just declaring it and that's it. You don't have what's called a concrete implementation where you're defining everything that method's going to do, right? You're giving all the specifics about that method. When you give all the specifics of a method, that's called implementing the method, and also can be referred to as a concrete implementation. Okay. An abstract method is a method that can be declared as abstract without an implementation. Okay. And always remember that derived classes must provide an implementation for this method. If not, the compiler will complain about that. The editor will too, if you're doing it within the editor. But abstract property is a property declared in an abstract class that has no implementation. Derived classes must provide the getter or setter for this property. Okay. Kind of the same concept here. Didn't really mention this, so you can also a sealed class. A sealed class is a class that cannot be inherited. Once a class is marked as sealed, no other class can derive from it. Right? A sealed property is a property in a derived class. So you can have a sealed class, so that's going to be basically at the top level of your class, right? When you define your class, you're saying it's sealed, so that's the whole class. But you can also have a regular class, a regular parent class, and have just a sealed property. So a sealed property is a property in a derived class, so it can be derived. The class can be derived, but that cannot be overwritten, so you cannot overwrite the property. Okay. Prevents additional modification of the property. A sealed method is the same thing. So basically, it's a regular. You have a regular uh, parent or super class, right? That has a sealed method in it, and if it's a sealed method, you cannot the derived class cannot overwrite that. Right? Um, Implicit and explicit casting. Yeah, that's going to be a. So let me see if there's anything else I really wanted to. Some of these concepts we're going to need to go over a little more.